we got negatives and positives here, right? So we got to think about, the only thing that makes decimals tough is the direction, kind of. So like if I was going to do 2.45, where would that be? To the right or left?
Left.
2.45.
Right.
To the right. And then now I'm focused on 2, right? I've got 2.45 or 43 or whatever. Okay? Where should I go from the 2? Should I go to the right of the 2 or the left of the 2?
Like towards the 3.
It's right because it's more than 2 but less than 3, right? So I'm going to mark it right here at 2.45. So that's really not that hard on the positive direction. The negative direction, some kids get confused, and I'll show you why. Let's say I had negative 2.45. Here's negative 2. Where do I mark negative 2.45? Is it to the right or left? It's to the left. So remember, this is continuing in a negative direction. So if I went 0.45 more than 2, I've got to go 0.45 less. See how these come into play? Less than 2 here. So this is where kids mess up usually, is when they go in a negative direction. I have a lot of kids mark negative 2.45 over here. You with me on that? That's the only real big miss on decimals. So even decimals are easy. So what are some other things that you'd have to identify that are hard?
Fractions.
Fractions, very good. What type of fractions are hard? Can you identify a half compared to a fourth?
Yeah.
Okay, so obviously a half and a fourth are between 0 and what? 1, right? So where's a half compared to a fourth?
In the middle.
Is a half to the right of a fourth, or is it to the left of a fourth?
To the right.
It's to the right of a fourth. It's right in the middle. That's a half. This is a fourth, right? That's pretty easy even if you're 0 to 1. Where it gets complicated is when we start having what's called improper fractions. What's an improper fraction?
So like,
Does anybody know? And you're going to have to write this in your notes. So write down improper fraction. Does anybody know what an improper fraction is? It's where the numerator, the top part, is bigger than the what?
bottom.
The bottom part, denominator. Okay, everybody write this fraction down and let's see if we can have a little number sense with this, okay? Let's put down the number 16 thirds. 16 thirds.
That's 5.
These are difficult, a little bit more difficult. Now, somebody said, who said 5? Ken, did you say 5? Okay, how did he get 5? It's around 5. I mean, it's not 5, but it is around 5. How did he get the 5?
Divided.
He divided it in. So, sorry I do this old school, and if you do it a different way, fine. But this is the way I've done it for a million years. So, I just say, how many times, what number could I multiply to 3 that is close to 16 without going over? Right? That's what I'm asking myself. What number do I multiply to 3 that is close to 16 without going over?
5.
And the answer is 5, right? So I go 3 times 5 is
15.
15, subtract it. This remainder becomes the other part of the fraction. So it's 1, that's the remainder, over the divisor. 5 and a third. Okay? So what did I change it to? What did I change this is called a what again?
Improper.
Very good. Improper fraction. What did I change it to? What's this called? Anybody know what that's called? It's called a mixed number. It has a whole number part and a fraction part. This is a mixed number. So you want to write that in your notes too. A mixed number has a whole number part. Remember how we talked about whole numbers yesterday? Okay, it's going to have a whole number part, and then it's going to have a rational part. Remember we talked about rational numbers? They're fractions. So it's going to have a whole number and a rational part. That's a mixed number. This is called a what? Improper fraction. These are hard to graph to start with, right? Because you have to change it from this to know where it is on the number line. So I'm going to extend this number line out. How come I'm extending the number line out?
Make it bigger.
I got to go past what?
5.
5, see? So I got to go, okay, now I got 4, now I got 5. Do I go all the way to 6?
Yeah.
At 5 and a third? No, I'm not going to go quite there. I'm going to go a third of the way from 5 to 6. So I'm going to start at 5, go a third of the way, 5 and 1/3, or 16 what?
16
Thirds. Okay, because that's what the question asked, is where's 16 thirds. So one of the key tricks is changing improper fractions to what? Mixed numbers. Okay, that's going to be one of the key tricks as we do our number lines outside here in a minute. Okay, is we want to be able to do that. We got to be able to do that to get some number sense, right? If I go negative direction, just remember it just continues in a negative direction. So this would have been to -5 and a third more in a negative direction. Just remember, negative just means direction. Don't get all confused with negative. It's just a different direction. Positive is one direction, negative is another direction. Okay? All right, let's talk about one more thing that has to do with number sense. And I don't know if you can think about this, but we have fractions, we have decimals. What else makes them hard? Think about your chart that we had yesterday. Which other values on that would be hard to mark on a number line?
Pi.
Say what?
Pi.
5? 5's easy. Oh, pi! Pi. Sorry, I didn't hear you. Dang lawnmower and crap. So, yeah, so we got pi. What type of numbers are those?
Irrational.
Irrational, right? Those irrational numbers are sometimes hard. The hardest ones are square roots. Okay, let's think about this for a second. Let's do square root of 20. Where is that? Here's the key. You need to know your perfect squares. We're going to write this. Write it down. We're going to do perfect squares from 1 to 225. Okay? So let's do the perfect squares from 1 to 225. First perfect square is 1. Why? 1 times 1 is?
1.
Okay. What's the next perfect square?
2 times 2.
Which is?
4.
4. I'm listing the perfect squares.
3 times 2.
So by the way, I'm going to write this equals 1 times 1. I'm going to write this equals 2 times 2. Then I'm just going to go like this. What does that mean? It's going to continue to follow that what? Pattern, right? Remember how we talked about math is just following a pattern and being able to figure out how it flows. So what's the next one, Callie?
First one. What was that? 111?
So, oh no, sorry, that wasn't 11. Sorry, I'm just doing quotes like that.
Oh,
So this is 1 times 1, that's 2 times 2. This would be what?
6.
3 times 3 is, 3 plus 3 is 6.
Yeah.
3 times 3 is 9. Remember, we're multiplying. Okay, so 6 wasn't a bad answer. We're going to multiply, not times. Okay. All right. What's the next one, Mackenzie? This was 3 times 3 is 9. What's the next one going to be? 4 fours. You can add them. What's 4 and 4? 8, and then 2 8s is 16. That's how my grandpa did math. He didn't know times tables for nothing. And he would just say, all right, I got 4 fours, so 2 4s is 8, 2 sets of 8, 16. See? And that's how he'd do 4 times 4. So if you don't know your times tables, just start adding. Okay? Next one, what's it going to be? What's your name? Braylee? Braylee, what's the next one?
25.
25, very good. What'd she do?
5 times 5.
5 times 5, very good. Next one, what's your name?
Camden?
Camden?
Canyon.
Canyon?
Yeah.
What's the next one?
36.
36, how'd you get it, Canyon?
I want 6 times 6.
6 times 6, very good. Okay, everybody should start thinking ahead now, right? What's the next one? Gannon, what's the next one?
9 times 9.
Well, we got, this was 6 times 6.
Or 7 times 7.
So 7 times 7, what's 7 times 7?
41.
Pretty close.
49.
49, that's pretty close. 49, okay, that's 49. And again, you can write these out to the side if you want. You can write 3 times 3, 4 times 4, so forth. You know what I mean? All right, Dakota, what's the next one?
Struggling on that one. 8 times
8 times 8, which is what? What's 2 8s? What's 2 8s? What's 8 plus 8? 16, double that. 32, that's 4 8s, right? So go 32 plus 32, that'd be 8 8s. So what's 32 plus 32? What's 3 plus 3? 64, very good. So again, if you don't know your times tables, don't worry about it. Just think about adding and remember that's all this is. Multiplying is adding. It's just adding groups of 8. So I need 8 groups of 8. So think about that. 2 groups of 8 is 16. And then 4 groups of 8 is 32, because it's 16 plus 16. And then 8 groups of 8 obviously has to be 64, because it's 32 plus 32. So you can do it in your head. Math, doing the multiplication in your head is actually just breaking it into addition. That's all you're really doing. Okay, next one. What's it going to be? What's your name?
Nick.
Nick.
81.
81. Very good. What'd you do, Nick?
Times 9 and 9.
9 and 9. Very good. Okay. What's your name?
Addie,
Addie, what's the next one?
100,
100. Why is it 100?
10 times 10.
10 times 10. Okay. What's your name?
Ryder,
Ryder. What's the next one?
121,
121. How did you get that, Ryder?
11 times 11.
A lot of people don't know that one, but it's 11 times 11 is 121. Okay? If you need to start taking your calculators out, either on your phone or just in a calculator, and tell me what 12 times 12 is.
144.
144. How about 13 times 13? Anybody know that one? If you need to, take out a calculator or, like I said, your phone.
169.
169. That's 13 times 13, okay? And then 14 times 14,
196.
196, and 15 times 15.
225.
Okay, those are the ones that I think you really need to know. If you can go that far, you're pretty good. Now, what do we mean by number sense and why does that matter? Because all square roots are between those suckers. Okay? Square root of 20 is where? Think about these numbers over here that are perfect squares. Where's the square root of 20 going to be between? Who thinks they know? Raise your hand if you think you know. Okay. Jacoda, what do you think it is?
5 times 5.
So it's less than 5 times 5, right? Which is 25, because square root of 20. So it's going to be less than 5, but more than what number? What's your name?
Sally,
Sally, it's more than what number?
4.
More than 4, because 4 times 4 is 16. So I know it's between 4 and 5. Right? So on my number line, when I'm marking square root of 20, now, is it closer to 16 or is it closer to 25? 20. It's a little bit closer to what?
25.
Think about it. How far is 20 from 16? 4 spots. How far is 20 from 25? 5 spots. So it's a little closer to what?
16.
To the 16. So it's a little closer on the number line to what? To 4. See how it's just a little closer to 4? And so this is square root of what? 20, and that's where I would mark it. Okay? If you know the perfect squares, you can do square roots all the way up to anything below 225 in your head. Like you don't have to have a calculator. You can say it's between certain numbers, right? Everybody try this one right here, okay? Let's try the number 92. Okay? Where between what two numbers is the square root of 92 and what number is it closer to? That's the question. Think about it in your head first, those two questions. Between what two numbers is the square root of 92? Okay, square root of 92. Between what two numbers is the square root of 92? And which number would it be closer to? Okay? Do you have those answers? What's your name?
Dylan.
What is it?
Dylan.
Dylan, what do you think?
9 and 10.
Good. How did you get 9 and 10?
Because,
You looked over here, right?
yeah.
81 and 100, 92 is between them. So we know it's between 9 and 10. Okay? Now, is it closer to 9 or is it closer to 10? What's your name?
Griffin.
Griffin, is it closer to 9 or is it closer to 10?
10.
What am I really asking when I'm asking that? I'm asking if 92 is closer to 100 or if 92 is closer to 81. What's it closer to?
81.
100.
100. 92 to 100 is only 8, and that's why he said 10. 92 to 100 is only 8 spots. 92 to 81 is like 11 spots, right? So it's a little bit closer to 10. So if I was to mark this on a number line, again, coming out here, let's say this was 9 and this was 10, I would actually mark right about there. Can you see how I'm closer to 10? And I'm going to say, hey, that's square root of 92. Okay, everybody got that? This is all number sense. Do you know how to do decimals? Do you understand positive, negative? After that, do you know how to change improper to mixed? And after that, do you know your perfect squares? That's number sense. If you know that stuff, all of a sudden, you don't need a calculator to do it. Okay? One other thing that I taught you that was number sense today was if you don't know your multiplication, group them and add. Okay, that's number sense. You don't have to be great at math to have number sense. What you have to be able to do is think through where numbers are on a number line. Okay? And that's how that works. All right, so that's all on number sense. Inequalities are pretty easy. Greater than, less than. The key is on this one, and you want to write this in your notes. The key to inequalities is always read from the variable. Always read from the variable. Okay? Because kids have a problem with that sometimes. Let's say we had this. And I had this.
And remember, a variable is your ABC or your
Right, your letter.
alphabetic number.
Yeah.
Your letter.
Sorry, I use math terms all the time, and Kate has to stop me and say, hey, wait, they don't speak math. You will be. You'll speak math eventually. But math is its own language. Did you guys know that? When you go to college, some of the colleges will say you have to take a foreign language. But a lot of them, guess what they'll substitute for a foreign language? Math. Because they figure it is another what? Language. When I say inequality, I'm hoping you understand what I'm saying. It means something greater or less than something, right? But are these two the same? How many of you think those two are the same? What hint did I just give you?
They're the same.
What hint did I just give you, though? Always read from the what? From the variable. Don't read from the inequality. That's where you get in trouble, actually. Read from the variable. What does this say?
X
Is greater than 3.
What does this say?
X is greater than 3.
Less.
X is greater than 3. Those are the same. If I read from the what? Variable. That's the key. Those don't look the same, right? The inequalities are swapped, but reading from the variable, they're the same. And that's where kids mess up, is they don't always read from the variable. Always read from the variable. So how would I mark this on a number line? So here's 3, here's 4, and here's 2. That's the only ones I really care about, just so I know direction, right? Okay, so here's 3. How do I mark this on a number line? X is greater than 3. I go to the right of 3, okay? I'm going to the right of 3. Is that all I do?
No.
What else, Nick?
You circle the 3.
Good, I'm gonna circle the 3. I'm gonna drop this down so you can see it. Do I fill that in, Nick, or do I leave it like that?
Leave it like that.
What if it was like this, Nick?
Then you would circle.
Then I would fill in the circle, because that means it's equal to or greater than. Is there any question on these? I don't want to go over these a lot because I think you guys already understand them, don't you, pretty much? Okay, so it doesn't mean, and some teachers teach this, oh, it points the direction you're supposed to go. Well, if the variable's on the left, it does. But what if the variable's on the right?
Nope.
Then it doesn't. So I don't like saying, hey, it points the direction you're gonna go. Elementary teachers, if you ever do elementary,
Don't do that.
don't do that. Okay, teach them to read from the variable, because that's the key. So otherwise they get confused as they get further up, because the variable can really be on either side.
Yeah, that makes sense.
So make sure you read from the variable greater than 3. These are both x's greater than 3. Circle it if it's not equal to, fill it in if it is. Okay, everybody got that? So not really super difficult. Greater than, less than, pretty easy. Okay, now we're going to go do number lines. So we're going to go outside. Pair up. Well, how many we got?
I'm 16. I'm not.
For everybody to have one? Oh, then we can just, yeah, that'll be good. Then we can spread out and we don't have to wear our masks when we go outside, so. Okay, so grab a thing and grab a chalk and then we'll go outside. You can take your mask off when we're outside. You can turn that off.
Do you want us to